This is part 3 of section 8.3. We're talking about simplifying radicals. Okay, so I want to simplify the square root of negative 675. Now, again, we will learn how to deal with square roots of negative numbers later, but remember this is an even index. Okay, and we are not allowed to have a negative on the inside of an even index. This is not a real number. Okay. All right, so let's talk about dealing with square roots of variables along with our numbers. Okay. So here we just treat it like two separate problems. I want to find the square root of 18, and I also want to find the square root of m squared, and it will all go together. Okay. Well, the square root of 18 we've calculated twice already. It is 3 times the square root of 2. Okay, so I'm gonna write that down right here. The square root of 18 is 3 times the square root of 2. Okay. Now for dealing with variables, I mentioned earlier that we can think of it like a division. This is an understood 2 right here. Does 2 divide evenly into 2? Yes. 2 divides into 2 one time. So I'm going to have an m to the first power on the outside. If I had any remainder, that variable would be stuck on the inside. We're going to work some like that, okay? But my answer to this is 3m square root of 2. So the square root of 18 is 3 times the square root of 2. The square root of m squared is m. And again, we're told our variables are positive numbers now, so we don't have to worry about that. Okay, so let's do negative square root of 25, t to the 7th, s to the 20th. There's a negative on the outside, which is always allowed, so we've got that negative. 25 is a perfect square root. Square root of 25 is 5, so I don't have to worry about doing a prime factorization there unless I just want to. And if I just wanted to, I could reuse either of these right here and have 5 times 5, have a pair of 5s, so it would move up to the outside. Okay, so the square root of t to the 7th. How many times does 2 divide into 7? Well, 2 goes into 7 3 times with a remainder of 1, right? This is how we first learned to do division when we were in elementary school. 2 divides into 7 3 times with a remainder of 1. This tells you your exponent on the outside. This tells you your exponent on the inside. So I'm going to have t to the 3rd power, and inside my square root, I'm exaggerating my space here because I still have to deal with this s to the 20th. I'm going to have a t to the 1st power on the inside. It went in 3 times with a remainder of 1. Okay. Now, why does that work? Let me show you real quick. I could think of a quote-unquote prime factorization of t to the 7th as t times itself. That's 6 times and 7 times, okay? It's a square root, so I'd be looking for pairs. I would have a t that's stuck on the inside. I would take a t out for each of these, multiply them together. T times itself 3 times is t cubed. So this is what's going on every time you have a variable, but I think you can see why you would not want to write it out this way. Okay? All right, so let's do this one. 2 divides into 20 10 times exactly with nothing left over. So I'm going to have t to the, not t, s to the 10th power on the outside. And there's no s on the inside. Okay, well technically I guess you could think of it as s to the 0 power, but we know that anything to the 0 power is 1, so there's no reason to multiply by 1 on the inside. So this answer, written a little bit better, would be negative 5 t cubed s to the 10th. Exaggerate your space so you can remember that it's a square root of 10. This is what I meant earlier about not letting this drift over and become a 10th root. You don't want to do that. Okay, so let's do the cube root of 64, a to the 16th, b to the 14th. Okay, so the cube root of 64. I glanced through this to see if I have 64 written anywhere. I do not. So prime factorization of 64. Okay, Well, 64 is divisible by 2, which is 32. And that's divisible by 2 again, which is 16, which is 2 again, which is 8, and then 2 and 4, and 2 and 2. You will start to recognize powers of 2 because I call this the 2 line. You're gonna see this a whole lot. Now I'm looking for a cube root, so I'm looking for groups of 3. I have 3 2s here. I have 3 2s here. So 64 is a perfect cube. The cube root of 64 is 2 times 2, which is 4. So the cube root of 64 is 4. Got that? Okay. Now the cube root of a to the 16th. 3 divides into 16. Well, that goes in 5 times with a remainder of 1, right? Okay. And the cube root of b to the 14th, 3 divides into 14. That goes in 4 times to give me 12, and its remainder is 2. Okay. So this is 4 times a to the 5th, b to the 4th, times the cube root of a to the first power, and we normally don't write that first power, b to the second power. Okay. Now, one thing I do want to remind you of is that one of our rules for being simplified was that our exponent cannot be larger on the inside than it is on the outside. So a square is okay because this is an larger index. When we had square roots, you're never going to have a second power on the inside because that second power is the same as your index, and that would mean you can simplify it further. Okay, so there's one property we have not really dealt with yet, and that is our final one right here. Okay, where we have an index and an exponent that are both divisible by the same thing, and we've got that on these two problems. Now, you can go ahead and calculate this all out. The fourth root of 50 squared, you square 50, you would go on and then simplify it from there, and it might be ugly. It probably will be ugly. But if you look right here, my index and my exponent, those are both divisible by 2. Okay? So if I divide this by 2, I get a 2. And if I divide this by 2, I get a 1. So this is the same thing as I'm going to put that index in there right now and that exponent in there right now, although you can see that those are not normal numbers. That's not the way we would normally write this because we normally don't write a first power. And a square root, we normally don't write the 2 there. That's the understood 2. There's an understood 1 there. So I'm really just looking for the square root of 50. Do I have the square root of 50 on here anywhere? No. Okay, so 50 is divisible by 2, which gives me 25, which is 5 times 5. So I'm looking for a square root, so that would be a pair of 5s there. So this is going to be 5 times the square root of 2. I could have multiplied this out, gotten the prime factorization of whatever 50 squared is, and then found the fourth root of it, but I still eventually would have needed to go back down to a square root because that would never be completely simplified. It's much easier if you look at this first. Reduce these numbers. It's just like reducing a fraction, so you have smaller numbers to work with, and then go from here. Okay, look what happens right here. I have the 10th root of x to the 25th. Okay? So we could do this as 10 divides into 25 how many times and then simplify from there. Or I could just recognize that both of these numbers are divisible by 5, get it down to a smaller kind of root, and it will be much easier. Okay? 10 and 25 are both divisible by 5. If I divide 10 by 5, I get a 2. Divide 25 by 5, and I get a 4. So what I have, divide by 5, you get a 5. Okay, I don't know where that came from. Okay, so what I really have here is I have a second root, a square root of x to the 5th power. And of course, we don't normally write that 2, but it's not, it's useful here because 2 divides into 5 how many times? 2 goes in 2 times with a remainder of 1. So this is going to be x squared times the square root, I'm dropping the index now, of x to the first power.